Okay, class, so this is for inclined plane. So when you look at this inclined plane, there's one, normally they will be given one angle here, and there will be one kind of thing that with certain mass. Okay, let's say the mass of this block is m. So we have to look at the touching point of the surface and the block. You see that this is the surface touching point. So when you have the touching point like that, and then the block is placing on this position, so there will be a normal force, that the normal force always 90 degree to the surface, right? And then the weight of this thing will be the weight of the block will be in this direction because it is due to the attraction of gravitational force. So the mg will be here, and then this is what you call reaction force, normal force we call it. Okay, so again we have to look at the vertical component and the horizontal component. So now we are no longer looking at this surface, but we are looking at this surface. Okay, so the vertical component will be this side, okay, and the horizontal component will be this side, right? Okay, that it will pull the whole thing down, right? So we have to look at different direction. So now you see that this is 90 degree, this is theta, so this one will be theta minus 90 degree, right? So when this is theta minus 90 degree, this is 90 degree, then this one will be theta. Okay, so this is theta, means that the angle here is theta. So I have to redraw another triangle using this one, since that this is all the force that acting on this. So you know that this is mg that acting towards the center of the earth, and this will be the resultant force that you will see. Somehow the block will slide down the inclined plane, right? So this is the motion, and reaction will be here, will be equal. It will be equal because Newton's third law said that action will be equal to reaction. So we have another new triangle here. So this is 90 degree and this is theta. Okay, so what is the value of this thing here? The value of this thing here will be mg cos theta, right? Okay, because it is beside the angle. Okay, so if you don't understand, you can actually look at this triangle, and then we know that cos is actually beside, this is what we want to find, divided by the longest one, right, mg. So we get x equal to mg cos theta. So this is actually x lah, so you can use any symbol. Okay, probably x will make you confused, then you just use a or whatever. And then what is the magnitude of f then? The magnitude of f, you see that we still refer to the new triangle that we draw. So f, you see that it is opposite of theta, right? So opposite of theta, we use sine, right? So you see sine theta equal to f divided by mg. So your f now is mg sine theta. Okay, so the force acting downward will be mg sine theta. In case you have frictional force that acting in opposite direction, then you have to minus mg sine theta minus the frictional force. Okay, let's say it's fr, small r, then that will be the resultant force you get. Okay, so the main point that you must get it here is that you cannot use the original triangle that given, because that is not where the force acting on it. So you have to redraw a new triangle, that is this thing, new triangle. You see this new triangle, right? New pen. Okay, new triangle here, that it make up from all those new forces. This is the weight, this is the resultant force, and this is due to normal force, right? Okay, so you have to redraw this triangle. If you're able to draw this triangle, you're able to solve the whole problem. Okay, that's all for this inclined plane problem.